Hi, I'm Dr. V. Koteswara Rao, working as Assistant Professor of Chemistry, Geetham School of Science, Hyderabad campus. In this session, I'm going to explain the working principle of glucose monitor. India is going to attain the status of world capital in diabetes. The causes of diabetes are many, but majorly due to the socio-economic reasons or conditions. The diabetes or the amounts of sugar present in the glucose is monitored or measured by an individual using glucose monitor, which is available mostly in every house. The amounts of these glucose levels are measured in terms of milligrams per deciliter, but how the glucose monitor is working is not known by many. Here, I am going to explain the working principle of glucose monitor. In 1965, the company Amos has developed the first blood glucose test strip, where the glucose oxidase was used as an enzyme. Then the people have taken a drop of blood and it was placed on the test strip. And after 60 seconds, the blood was washed away. The generated color was then compared to a chart that is present on the bottle as shown here and measured the semi-quantitative assessment of blood glucose. But it was not that much accurate. Later, the technology has been improved a lot. So there are a variety of glucose monitors are available to measure the glucose present in the blood. So here I'm going to show you one of the glucose monitors that was developed. Here the value that is 158 milligrams per deciliter is nothing but the amount of glucose present in the blood, which is expressed in terms of milligrams per deciliter. Here it is 158 milligrams per deciliter. This is the summary of developments in the evolution of blood glucose systems for self-monitoring. In this session, I'm going to explain about the working principle of glucose monitor, where the sensor is modified with an enzyme. So it is also called as the enzyme modified electrode, which was developed in 1987 by a company called MediSense. So there are different enzymes are also available. So depending upon the type of enzyme that you are interested, different electrode sensors are also available. If you take only the metal electrodes, they do not have any practical biological applications. So the electrodes were modified with or coated with the enzyme. So the modified electrodes are also called as enzyme modified electrodes. Since here we are using glucose oxidase as an enzyme, so the electrode is also called as a glucose modified electrode. The modified electrodes can also act as a potentiometric or ampermetric sensors. The sensor means which senses only a particular species of interest and ignoring the other species present in the analyte sample. A number of enzyme-based sensors are available in the market. An example is a glucose sensor that is widely used in clinical laboratories. So this is one of the glucose ampermetric sensor that is available in the market, which consists of three different layers: outer layer, middle layer, inner layer. This is a biosensor, which consists of three layers. The outer layer is a polycarbonate film that is allowing only the glucose molecules and ignoring the other constraints such as proteins, plasma, and other constraints present in the blood. Then the glucose present in the blood go to the next layer, that is middle layer, which is coated with an enzyme called glucose oxidase, which is an immobilized enzyme that is coated on the middle layer. Then the molecule goes to the inner layer, where the inner layer is coated with the cellulose acetate membrane, which is permeable to only the small molecules such as hydrogen peroxide. Now, you take the device or the strip and put a little amount of blood, or the device is immersed in a glucose containing solution. The glucose diffuses through the outer layer, where the outer layer is coated with polycarbonate, which is allowing only the glucose molecule and ignoring the other species present in the blood sample. And then this goes to the second layer, which is having a immobilized enzyme, that is glucose oxidase, where a catalytic reaction is happening and the glucose is undergoing oxidation and produces gluconic acid and hydrogen peroxide. So hydrogen peroxide is a small molecule which is allowed through the third inner layer, that is made up of cellulose acetate, which allows only the small molecules such as hydrogen peroxide, where the hydrogen peroxide is further oxidized to produce oxygen and 2 electrons. So the number of electrons that is produced during these electrochemical processes is directly proportional to the amount of glucose present in the blood sample. If the sensor is acting as a potentiometric sensor, then potential difference is developed, which is directly proportional to the amount of glucose present in the blood sample. Or if the sensor is acting as an ampliometric sensor, the current can be measured, which is directly proportional to the glucose concentration present in the blood sample. Like this, once you measure the amount of glucose present in the blood, that is displayed on the glucose monitor. Here the animation shows the measurement of blood sugar. Here you take a drop of blood and put it in the strip, where you can see the value that is displayed on the monitor. For example, here it is 158 milligrams per deciliter. So whatever I have explained, the electrochemical process were observed, and finally you can measure the amount of blood glucose present on in the blood sample. Currently, continuous glucose monitors are also available in the market. Here the sensor is fixed to the body, and which senses only the glucose present in the blood in the body, and the resulting value or amount is displayed on a mobile phone or a device. So you can measure continuously the glucose present in the blood continuously. That's why these are also called as continuous glucose monitors. Like this, we can understand the working principle of glucose monitor. I hope you have enjoyed the session. And finally, I thank you all for your attention.